Okay, so in part C, the scenario's changed a little bit. Find the magnitude of the force in the stick. So the boy is now making the box slow down, and it comes to rest after travelling 0.8 meters. So the friction force is still the same. So in part A, we had this scenario, didn't we? We had a box. There was a boy pulling a 3.2 kilogram box, and he pulled it with a tension in the stick of 18 newtons. And because he was pulling it to the right, there was a force of friction acting to the left, because it was a rough surface. And we marked on the direction of acceleration with a double arrow as such, and we even found that out. Okay, now the scenario's changed a little bit. Okay, he's now causing the box to slow down, alright, and it's coming to rest after travelling 0.8 meters. Now we're going to come across this idea about tension and thrust. So a stick, for example, can exert both these forces. Now you should think of tension as a pulling force, alright? You can pull something with a stick, alright, or with a rod, okay? So, you can pull something towards you. If that happens, so say there's a box attached to like a stick, alright? If you pull it towards you, the force would be tension, it would be going towards the person, alright? Maybe the person's here and he's pulling it, so the tension is going towards him, okay? Alright, now thrust is another force that can happen in a stick, and that's when you push something with a stick. So if I push this box to the left with a stick, for example, well, it would be a force called thrust, which we also mark with T. Alright? It wouldn't be tension, because tension is always a pulling force, you're not pulling it, but there must be a force that's allowing you to push it. The stick isn't collapsing in on itself, alright? So there is a force acting towards the box, and that's what thrust is. Okay, so it's seeming like this in this example there is going to be a thrust force. Alright, so anyway, let's get back to the question. So I'm going to use this information. It tells me that the box, it's slowing down. It comes to rest after traveling 0.8 meters. Alright, so we're going to go ahead and use a Suvat equation. So I'm going to write out my Suvat list. And I'm going to work out this deceleration. The box is coming to rest, it's slowing down, so that's going to be a deceleration I'm working out, alright? Now the time taken, alright, is, or in fact, no, we don't know the time taken, we're not going to need it, but we do know it comes to rest after 0.8 meters, so the displacement is going to be 0.8 meters. The initial speed is 2.1, because it's still travelling at 0.1 meters, then it starts to slow down, so we need that from part B. 2.1, and then it goes to rest 0. So recall, to use the Suvat equation, we need to know 3 of the unknowns and then a 4th we're trying to find out, which we do. So we're going to be using v squared equals u squared plus 2as. So these are all on the formula book, on the formula sheet. So v squared equals u squared plus 2as. So I'm going to go ahead and substitute in what I know. So I've got 0 squared is equal to 2.1 squared plus 2 times a times 0.8. And we're just going to go ahead and solve this. So 0 squared is 0, 2.1 squared on our calculators will give me, so let's have a look, 2.1 times 2.1, 4.41. 2 times 0.8 is 1.6, so I've got 1.6a. Let's go ahead and solve that. So I'll take away 4.41 to the other side and then divide by 1.6, and I will get minus 2.76 for the acceleration. Okay, but we haven't finished the question yet. So we knew the box is slowing down, and it makes sense for acceleration to be negative because it's a deceleration. However, we're going to need to work out that force of thrust, okay? So the boy is actually, pushing the stick to make it slow down. It's moving to the right in part B. It's moving to the right, but then it starts to come to rest, and it's slowing down, still moving in that direction. Okay, so we're going to use this diagram. We're just going to assume t is acting to the right for a second. So we're going to use f equals ma and resolve to the right. So I'm going to write r to the right. So I'm going to use t minus 7 is equal to ma, so 3.2 times this acceleration we found out. And if I go ahead and work that out, I will get t is equal to 3.2 times minus 2.76. So that's 3.2 times minus 75625, and then I'll plus 7, I'll get minus 1.82. So we assumed on our diagram that the tension was acting to the right, so it was a pulling force, but because we've got a negative answer, it actually means it's acting in the opposite direction. It means it's towards the box, which means it's a force of thrust. So the force is a thrust of magnitude 1.82 newtons, and that's how you do this question.